All right, so in this module, we're going to look a little bit more in depth at the chemistry of polymer molecules. So we've been talking a lot about polyethylene, or PE, and we've talked a lot about how it has a carbon backbone. So in that we mean the carbon is bonded to each other in a long kind of chain, or kind of spine. You can think about it. And then there are hydrogen in groups on each carbon. In actuality, the actual polymer isn't a straight line like is sometimes written. It's more of a zigzag because there's a certain bond angle between each carbon. So it's more of a zigzag than a straight line. That's just something to kind of keep in mind. But polyethylene is a long chain hydrocarbon. So basically, as we kind of talked about, you can start with the simplest with one carbon and then two and three. This is a much larger hydrocarbon, which with a much higher molecular weight because it has more carbons and hydrogens involved. We also have paraffin wax, which is basically you can think of it as candle wax, is a much shorter polyethylene. So if you kind of think of this as a continuum, we have something like methane, which is a gas, carbon with four hydrogens, and that's a gas. Then we have paraffin wax, which is a short polyethylene, and it's kind of somewhere in between a liquid and a solid. And then the higher we go and get a much longer polyethylene, then we have a solid, right? Like we know in our plastic bags and so forth, which is polyethylene. And so those are, again, kind of the variations of these structures. And we know that there's a monomer that forms what is used to synthesize, and then it forms this repeat structure. And when we talk about repeat units, we often label these as the repeat unit. So carbon-carbon shows the backbone with hydrogens off of it. And then the N refers to how many of these repeat units we might have in the polyethylene chain. So when you see N, that means how many of repeat units are there, because it's repeating over and over and over again in this polyethylene long chain. And so it's important to kind of keep in mind that when we talk about polymers, the chemical formula alone is not super useful. And the reason I say this is because we have something called isomerism. And this is where we have the same chemical formula, but we can have different structures. And so for an example, if we look at C8H18, we can have multiple things that have the same chemical formula. We can have octane, which is, again, like polyethylene. It has carbon backbone with hydrogens off of it in every direction. And so if you kind of do the math there, you get C8H18. But we can also have this 2,4-dimethylhexane, where we have a much different structure. We have a lot different kind of carbon structure, and it's no longer a chain, right? There's kind of two branches going off of it. But both of these have the same chemical formula. So when we have same chemical formula but different structures, it's known as isomerism. So again, iso kind of means the same, and then mer kind of refers to the structure. And again, we can from polyethylene, we can also vary the hydrogens for other chemical groups to get other polymers. And so the carbon backbone is known as a vinyl polymer. So polyethylene is a vinyl polymer with all hydrogens. If we have a carbon backbone with all fluorines, we have polytetrafluoroethylene, or PTFE. If we replace one of those hydrogens instead with chlorine, we get polyvinyl chloride. So again, vinyl means that it's a vinyl polymer, so carbon-carbon, and that's PVC. And then again, if you replace one of those hydrogens for something else, some random R group, N group, you can make other polymers. So that's kind of why I put, you can insert a name here. So some other examples of that would be polypropylene for the CH3 group, polystyrene if you have a organic ring, You can make polymethyl methacrylate, PMMA, if you form this carbon other group here, right? So different N groups, different vinyl polymers.